4.2, yes. Hurry up, but we're going to just get started without you. 4.2. We have talked so far about standard form of a quadratic equation. What does that look like? Okay, that should look familiar. Standard form, y equals ax squared plus bx plus c. Yesterday, what did we call that form? Okay, remember? What did we find with it? Vertex. So that's the vertex form. It's on the board. I'll write it up here again. Y minus k equals a times x minus h squared. I forgot this. Okay, and that's the vertex form. We also sometimes call that the working form. Today we're going to talk about the intercept form. So the intercept form looks like this. Y equals a times x minus p in parentheses times x minus q in parentheses. And we'll look at why we're going to call that the intercept form in just a minute. Okay, so standard form, vertex form, or working form, and then now we're going to do intercept form. Now let's look at this example. This one is in intercept form. If I go y equals, I'm going to let x equal negative 3, and you'll see in just a minute why. If I let x equal negative 3, this is a positive 3, I'm going to let x equal a negative 3. So I have 2 times negative 3 plus 3 times negative 3 minus 1. Okay, so that's 2 times. Negative 3 plus 3 is 0. Negative 3 minus 1 is negative 4. What's 2 times 0 times negative 4? What's, yeah, 0 times anything is 0. So that's 0. So I know the point, negative 3, 0, is on my parabola. And guess what that is, what we call an x-intercept, because if y is 0, then it's on the x-axis. Okay. Now, I'm going to pick another value for x. Anybody guess what the other one's going to be? 1. So if I let x equal 1, then I get y equals 2 times 1 plus 3 times 1 minus 1. So I get 2 times 4 times 0. 2 times 4 times 0 is 0. So I know I have the point 1, 0 on my parabola. Okay. So finding the first 2 points on your parabola are relatively easy in this method, or in this, when it's in this form. Now there's another part that becomes relatively easy. Not quite as easy as finding the vertex yesterday, but not too bad. If I look at those 2 points and I know those 2 points are on my parabola, ideas about where or how I'm going to find my vertex. My x value for my vertex, where's it going to have to fall? On the negative 1 line. You are correct. How did you figure that out, Kathy? Yeah. You divide that space in half, right? From here to here, 1, 2, 1, 2, 3, 4 units across there, so it has to be 2 units away from the axis of symmetry. So if I draw my axis of symmetry, it's got to be right there. 1, 0 is 2 units away. Negative 3, 0 is 2 units away. So I know that x equals negative 1 has to be my axis of symmetry. So now if I know what my x value is, how do I find my y value? Substitute it back in. Different colors. Keep track like that. Okay, so I'm going to substitute x equals 1 into my original equation. So y equals 2, or negative 1, times negative 1 plus 3 times negative 1 minus 1. So evaluate what's in the parentheses first. I get 2 times 2 times negative 2. 2 times 2 is 4. 4 times negative 2 is a negative 8. So my vertex is at the point negative 1, negative 8. So at this point, now I can draw my parabola. I know it's negative 1, negative 8. These points tell me it needs to go up. It shouldn't be quite that wavy. Let's see if I can do better on this side. There we go. So it looks something like that. Does that make sense? Yep. That's what we're going to do with our graphs. You only have to do 3 points today.
That's pretty neat.
Okay, good. So let's do one more. Now I'm going to let you leave part of the work that I have on this one. I'm going to let you leave part of it out. So I'm going to do one more and show you exactly what I want to see on your graphs. So this one, I didn't put my y equals in here. I've got y equals negative 2 times x plus 5 in parentheses times x plus 1 in parentheses. What do I call this form? Intercept form. Okay? So this is the intercept form. So the first thing you need to do is you look at that equation and you tell me the two x-intercepts. Negative 5 and negative 1, because when I add this number to 5, it has to be 0, okay? So it's always going to be the opposite sign. So negative 5 and negative 1. So I can plot those right away. Don't forget to label your x and y axis. So I've got the point negative 5, 0, and the point negative 1, 0. Okay? Now, what's next? I need to find my axis of symmetry, right? So now you can count halfway between. Where's it going to fall? Negative 3. Now let me show you how you can do that with arithmetic. Okay? So you can show what you're doing. You say x equals. Now when we're finding halfway between these 2 points, what we're doing is we're finding the average of those 2 points. Remember how to find an average? Add them together and divide by 2. So I have negative 5 plus negative 1, or negative 5 minus 1, divided by 2. Negative 6 over 2, which gives me negative 3, which is what we got counting, right? Same thing, different ways to do it. So let's draw our axis of symmetry. At the point, or let's just label the axis of symmetry here. X equals negative 3. Okay. So now I need to find my y value. So you when x equals negative 3, so I get y equals negative 2 times negative 3 plus 5 times negative 3 plus 1. So I get negative 2, in parentheses I got negative 3 plus 5 is a positive 2. In the next parentheses, negative 3 plus 1 is a negative 2. So I get negative 2 times positive 2 is negative 4. Negative 2 times negative, or no, and then times negative 2. And then negative 4 times negative 2 is a positive 8. So I should have the point negative 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. And it goes down. My arm gets in the way there. That's what you need. Now, the last thing I want you to do is I want you to give it the ocularity test. You look at it. This is a negative 2 on front here. Does it make sense that my graph goes down? Yeah. It's times 2. So it's narrow as opposed to really wide. That makes sense. That's what I mean by giving it the ocularity test. You look at it, see does it match with what I know. Okay? So, not sure what it just did there. Okay. Things I want to see on your paper. Write your original equation. Tell me what the x-intercepts are. Make sure you and then graph them. Do label all 3 points. I'm going to let you have just 3 points, but I want them labeled on the graph. Show me how you find your axis of symmetry and label that. And then find your y value for your vertex and draw your graph. Don't forget to label the x and y axis. Okay? Okay, so that's what I want you to do on the graphs. We do have some other things. These should be reviewed. Remember this? Yeah. Okay. If I had this equation, y equals x plus 2 times x plus 7. I need to multiply them out. What does F stand for? Front or first. Usually we say first, but front would make sense too. O for outer or outside. I for inner or inside. And left. Okay? So, we take first terms together. So x times x is x squared. Outer terms, x times 7 is 7x. Plus the inner terms, 2 times x is 2x. And the last terms, 2 times 7 is 14. And then you always have to simplify, so I get x squared. 7x plus 2x is 9x plus 14. Now, what does that form look like? Remember we had 3 forms at the beginning? This is standard form. So if you want to take an equation in, what's this form? Intercept form. And you want to change it to standard form, here's what you do. You FOIL it out. You multiply. Okay, so let's do a couple more practical ones here. I have y equals x minus 4 times x plus 6. So, first, okay, x times 6 gives me 6x. Okay, inner, so x times negative 4 minus 4x. And negative 4 times 6 is minus 24. Simplify. Get x squared plus 2x minus 24. Combine like term. Okay, I am going to go ahead and do this last one because it's kind of a special case. X plus 5 times x plus 5 is the same as x plus 5 squared. Okay? So let's go ahead and look at this one. If I have y equals x plus 5 times x plus 5, I still can do it the same way. X times x is x squared. Outer terms, 5 times x is 5x. Inner terms, 5 times x is 5x. And last terms, 5 times 5 is 25. So combine like terms. Okay, now one reason I wanted to do that one is because if you remember back from algebra, forever ago, does anybody remember the shortcut to square a binomial? I'm going to tell you the shortcut. If it makes sense and you remember it, use it. If it doesn't, just spoil it out. No problem. Okay, to do the shortcut, you take the first term squared, so x squared, plus the first term times the last term times 2. So 5 times x times 2, 10x, plus the last term squared. 5 times 5 is 25. Like I said, if you remember the shortcut, use it. If you don't remember the shortcut, multiply it out, and then you'll be sure you got it right. Okay, so now let's look at some and how they're going to look on your assignment. What happens when I have a negative 2 out front? So let's look at that one. What you're going to do is you're going to multiply the two binomials. Binomial meaning the ones with two terms. X plus 5 is a binomial because there's two terms. X minus 8 is a binomial, so there are two terms. So you multiply the two binomials first, and then you distribute your negative 2. So the first step, you're just going to write down the negative 2. I'm going to move it down a little bit, folks. I have room to draw my little lines. X times x is x squared. X times negative 8 is 8x. 5 times x is 5 times negative 8 is 40. Okay, so you do that first. Go ahead and simplify it before you distribute. Just makes life a little easier. 8x minus 5x is negative 3x minus 40. And now once you've got that all taken care of, now you distribute your negative 2. So I have negative 2 times x squared is negative 2x squared. Negative 2 times negative 3x is plus 6x, and negative 2 times the negative 40 is plus 8. Now you're in standard form. Okay? Now last one, this is the most complicated one that you're going to have. F of x equals 4 times x minus 1 squared plus 9. Now, it looks like this. Again, if you remember the shortcut, by all means use it. If not, let's just spoil it out. But in order to do that, you need to write it a little different way. So I get f of x equals 4 times x minus 1 times x minus 1 plus 9. Okay, so now when you look at that, there's a lot going on. So what we're going to do is we're going to focus on the binomials first. Leave everything else alone. So I've got 4 times outer term, or first terms, x times x is x squared. Outer terms, x times negative 1 is minus x. Inner terms, negative 1 times x is minus x. And last terms, negative 1 times negative 1 is plus 1. still this plus 9 coming along to the right. And we're going to do like we did before. We're going to simplify inside the parentheses before we go any further. So 4 times x squared minus 2x plus 1 plus 9. Now, we need to still get rid of those parentheses, so we're going to distribute that 4. So I get 4 times x squared is 4x squared minus 8x, and 4 times 1 is 4, so plus 4 plus 9. Now the parentheses are all gone. I can finish the problem. Get combine like terms. 4x squared minus 8x plus 13. There's my standard form. Okay? Question. Okay, so those are the things you're going to be working